Welcome back to a lecture series on digital image processing. So in this lecture, I am going to discuss about the image enhancement, especially on contrast enhancement. The meaning, inbuilt meaning, you can have it over the title itself. The satellite image and the digital satellite image needs to be enhanced. It means the interpretation capability of the image has to be increased, or the features, distinction between the two different features has to be increased. It is possible if you use the maximum possibilities of the image display in the satellite data. Where it plays a role, we have color depth. There is a parameter called a color depth. The study of color depth already we have discussed as a radiometric resolution. The capability of the satellite data is to take information initially between 2 to the power of 8. Now it is increased in the recent satellite data into 2 to the power of 12. It means 4018, 0 to 4018 gray levels you can have it between black and white. From 0 is black and 4000 plus is white. What does it mean? It means the characteristics of the digital data with respect to every features can be discriminated into a number. But normally we use 0 and 255. So whatever the reflectance you get in your area needs to be stretched, needs to be enhanced. Maybe you get only a very limited portion of reflectance. The possibilities of the computer system or your image processing software will be able to work with 0 to 255. It means you will have to enhance and the spectral regions of your area into the maximum. That is the basic concept of it. I think if I give with some examples, it will be very easy for us to understand. We will see images are enhanced. What does it mean? It enhanced for the better interpretation of features. It enhanced for the better interpretation of discrimination of object. So we are going to do contrast. It means contrasting black and white, contrasting light and dark could be done by using this technology. And as I said, you need better interpretation. Rather, you can tell effective display. Once if the effective display comes, if my eyes are feeling better to interpret the satellite data and can increase the capacity of visual interpretation, is the procedure applied to the images that is called contrast stretching. The procedures are applied to the image in order to effectively display the data for subsequent visual interpretation. It involves for increasing the visual distinction between features. That's what I insist in the introduction part. So the satellite data, if you look at the satellite data, you'll be able to see the red band, very high, brightness, and the other soil area with other tonal differences. No discrimination between the object by using contrast stretching will improve. Contrast enhancement will improve, and we will get more comfort on discriminating the different objects. That is the basics of image enhancement. Image enhancement, there are 4 options available in the image enhancement. Contrast stretching. Now in this lecture I am going to explain only image enhancement. Stretching, filtering, edge enhancement and linear data transformation. There are 4 sub-modules or 4 SA of contrast enhancement is there. We will see one by one how that this is going to be helpful for us. There is a picture they have given. You see you have a blue band. If you see your blue band, it looks like black in color, and it is a single band information of green. And if you put together these 3 band blue, band green and band red, we will get the true color of the image. But by looking at different tones, this is not appealing. You see you have your yellow tone in the blue band, you see it is suppressed. But you merge, you will be able to get this. This is of concept of black and white and color images, bringing 3 master colors together, blue, green and red. The same in satellite data. Concept of color composite happens by taking different tone, the information with respect to blue band, green band and red band. If you merge and then produce in the image processing software, you will get a true color of the satellite data. And what is the difference between true color and false color? You see, this is true color. Colors used here for the preparation of this image by using band 3, band 2, band 1. Band 3 is red band, band 2 is green band 1 is blue band. First band, second band, 3 band. You see, you have 3 false color composite, 3 acids of changes you can find. You see, if you use 1, 2, 3 RGB, your apple looks like blue color. If you use 1, 3, 2, it is not, this is RGB, this is 1, 3, 2 combination, this is 1, 3, 1, 2 combinations. This is true color, this is true color, 3, 2, 1, this is 3, 2, 1 true color. But you see the data, you'll be able to get the differences between this and this, the green object, and here it is a green, it is not the green object. This is how the false color you can generate by playing different bands together, mixing band like RGB or GBR or you vice versa. You just rotate whatever the interest you want to display. You will get better interpretation capacity of the object to describe. And this is one layer's list two images of Kakinada of band 1 blue band. This is green band. This is red band. This is infrared band. You see the infrared band, as I have already told you, infrared band if you use, because 100% absorption of water body, looks dark tone in the satellite data. Whereas you have, if you use other band, you will be getting reflections, your energy will penetrate up to some place, some distance, and you will be getting a small amount of reflections over this. This is blue band, this is green band, this is red band. If you mix these three together, and you will get your false color composite. And this is the false color composite of Kakinada, and this is very interesting. If you look at a clear picture that why that this red tone, you can go to field and check why tonal changes over here, what is the lake and what is the river meander, why it's acting over here. So many informations which we can derive from geological point of view. But if you put together and then prepare a false color composite, it will be easy for us to understand. And if I am interested on before going for contrast enhancement, I must know the pixel values of each band. This is a portion. If you just zoom a portions and select and then see what is the reflectance of 3 different bands. You see the reflectance percent is represented for band 1, 2, 3 and band 4 of this area. And similarly for turbid water, you see reflectance is increased from 42 to 50. That's what I said. When energy travels to a certain distance, whatever it present in between, it will start to reflect. Maybe a phytoplankton, maybe that suspended sediments in that area. The reflectance is more, reflectance is relatively less in the deep water. Similarly, you have to zoom and then see the different places, like this is the agriculture area, complete thick agriculture area, and this is the forest area nearby sea. And you see what is the difference between this in the green band and red band. You can find not much differences here, but in this band you can have higher reflectance here, but you have less reflectance in the infrared band. And similarly, you have to see the barren area. This is the open area. This is the sandy area, which will have higher reflectance in band 1, which has relatively less reflectance. So you have to correlate and understand that how each band behaves with respect to different features on its reflectance characteristics. This is very important for us to understand the reflectance characteristics. Otherwise, we will get we cannot understand why that this behaves. This is the curve generated for various bands, for various objects over band. This is the pixel value taken. This is the band information taken. Dark blue represents deep water. Light blue represents turbid water. Pink color represents agriculture. Green color represents forest area. And what happens in band 1, what happens in band 2, what happens in band 4, where it gets increased, where the distinction is more, that to those informations which you can use this type of spectral reflectance curve to understand about the different scene characteristics or the feature characteristics or the satellite data characteristics. Now what is, after looking all these images cited above, now we will understand, in order to improve the clarity of the image, contrast stress played a role. What affects the contrast stress of an image? If there is a question comes, what affects the contrast stress in the image? The clarity of the image generated either as hard copy or display device increases. The range of the value between minimum to maximum, if you enhance the range of values of the limited portions which is there in your area, it will increase the contrast enhancement. The dynamic range output, this is called DR. The dynamic range output, again it will increase either in the 8-bit black and white or 24-bit color images. The resolution of output device will double by using this contrast enhancement. And that's I said, what is contrast difference? The contrast difference is the value between maximum and minus minimum. Say for example, if my spectral differences of my area is between 50 and 100, 50 is minimum, 100 is maximum. If I want to know what is the contrast difference, it is max minus min. It means 100 minus 50. My result is only 50. But my possibilities of enhancing these images is 250. Then why should I want to work with only 50? If I am increasing this 50 differences into 255, there I am playing a role that the contrast enhancement over the image. If I apply contrast enhancement, I am more comfortable in doing all my research. What is the ratio between the contrast? Again the same simple 100 divided by 50, you get the ratio. The ratio is 100 by 50 is 2. Why should I want to have the ratio only minimum? I can have it the maximum ratio 8. Then I can play my images into, show my images better than what I have, what I am getting it in the raw image. This is one such example. The contrast difference and contrast ratio. You see the contrast difference is 37, contrast ratio is 3.467. But contrast ratio for 255. And you look at the graph here, my possibility is between 0 and 255. But my data will have only this much. The reflectance of this is only this much. What is the difference? It is the reflectance between 15 and 52. 15, it is from the lowest side. It means it is a black area. That's why your image looks like black. But I have the possibility to shift the lower into lower, higher into higher to see better discrimination. Similarly, another example, you see, this one you get, from black end. The differences is very less. Suppose if I get data at the right end, it means 255, you see it looks like bright. Why it looks like bright? Because my data difference is only 37 at the higher end. My data starts from 180 to 250, some difference is only 37 and ratio is only 1.1, but I could have up to 8. So this input histogram you will have to see, and if it is less, then you will have to think of contrast enhancement. Otherwise, you look at if it is in between, what will happen? The difference is 37, the CR difference is 1.8. So you become, your images, it's like, looking so dull. I am not so comfortable to use this data. I don't want to use this data. And you look at that, what will happen if your DN value, if you are not changing? No, your FCC will looks like this, your black and white panchromatic data will looks like this. But you have to enhance. Please try to enhance and then look at a figure. Look at satellite data, very beautiful, excellent satellite data. And it speaks. I could be able to interpret many informations over this. You see, this is a vegetation, this is a backwater forest area, and this is, beach ridges, old beach ridges, younger beaches, and all these things, I am so comfortable and I will be able to interpret thousands and thousands of information with respect to domain knowledge concern. Maybe if I am a geologist, I can look at why this is different, this object behaves, why there is a barren land here, what is the rock type here, why there is a color difference here, why I am getting a thick red color here, why people could not be able to do agriculture. So your image will start to speak, and then you will be able to interpret the images into various subdivisions of geology. So with this, understanding of contrast enhancement comes to an end. Thank you.